Welcome, everybody. I hope you're all well. You've each no doubt hit the ground running with the start of the new year. So a big thank you for joining us today. We really value your time. My name is Gretel and I'll be your host this afternoon. So just to share first on a technical note, as you will probably see above, that this webinar will be recorded today. And then also to ask that you stay cameras off and on mute while the presentation is on the go. And then before Anne Edie gets started on her Euclidean geometry presentation, which I'm sure you're all looking very much forward to, let me quickly take you through the plan for our time together. So I will be taking the opportunity to share with you a little bit about the support program the answer series will be offering teachers and learners throughout 2022. Then Anne will follow with her presentation, after which Susan and Jenny will share a little more detail about what we are offering this year. We will then follow up after that with popping a link into the chat to a feedback form where we ask, please, if you could take a moment then to share your feedback with us. We have lots of valuable material to share with you, as well as an invitation to our TAS Teachers WhatsApp group. But we need your details from the feedback form in order to be able to do all of this. So it'll definitely be worth it for you to stay till the end to submit your form. Then once we have given you a couple of minutes for this, we will then give you a chance for questions, where we really invite and encourage you to ask whatever questions you're sitting with. So if you do have any questions during the webinar and presentation, please feel free to pop them into the chat as we go. I will answer, or the team will answer what we can directly. Otherwise, we will do our best to get to as many questions as possible in the Q&A session. Then on another technical note, for those of you that are new to Teams, there is a slight functionality difference if you have Teams downloaded or not. But fortunately for this, for today, this ability will not be, the difference will not be a problem, because you'll be able to write in the chat if you need to pop in a message or a question, or come off your mic, as you've seen a couple of people do already, and speak when the opportunity arises. Okay, so on to telling you a little bit more about our Maths Teacher and Learner Support Program for 2022. We are super excited to be sharing our very first live event of our support program with you today. Our program includes further live webinars throughout the year, as well as teaching videos that we will make freely available for a period of time during the teaching of a section. And the timing of this we've based on the ATP. And then a reminder also to all of you teachers that our ebooks are free for you. Then we will show you a little bit later in the after Anne's presentation, how to learn more about all of what I've just mentioned through our website. So I think that's all from me for now. So thanks, everyone, and I'll hand over to Anne for her presentation.
Yeah. Thank you, Grace, and lovely to be here, and welcome everybody again. So how to prepare for a presentation on Euclidean geometry in a relatively short space of time, given the topic itself. So many people in the world have a fear of maths in general, but geometry, very especially. I'm passionate about this topic for this very reason, and for several others. As teachers, not many of us can say we have mastered teaching it, and I don't know about you, but I love that I still get stumped by the odd question. But this topic holds the key to the door in maths. To succeed, you need to think, not just memorize and do. In other topics, learners can pass by reproducing standard procedures, but not in Euclidean geometry. So, clearly, while it is no simple task, I would like to discuss ways in which we can make this topic accessible, contained, even though it's vast, and even fun. The major issues that are interwoven in the entire presentation are these basic issues for which I just think are absolutely critical in the teaching of geometry. The language, number one, knowledge, logic, and then strategies. The language, number one, because If you know it, you can speak it, you can describe it, you can recognize it, and you can prove it. So there are a number of online booklets that is really what the whole presentation comprises of, which will be made available to you, as Gretel said, as soon as we have your details. We will be forwarding all this to you. I must say, I thought that I should perhaps split what I dump on you afterwards and what I present to you now, but I just decided to just put everything together, and I will whip through certain parts now in the presentation, which I feel will be of use maybe to your learners and for you in your teaching, but which are not necessarily part of today's presentation. So the very first booklet on teaching documents, you probably have all these documents, but it's just very nice when you are approaching the time of teaching a topic to have them all at hand, and that is what the aim of this particular booklet is. The contents, I will rather just go through the teaching documents in which they are. We all know by now that a year ago, the marks were swapped for trigonometry and Euclidean geometry to now being 44 Euclidean geometry. The time at which you're going to be doing it, this proposed, and I say proposed, not wanting to jinx anything in 2022. We don't want to use words like pandemic or anything like that. This is the proposed ATP as from Gauteng. I have run it and compared it with the Western Cape, but not with any other province as yet. So it's very much a proposed one that I don't want to have to answer for if I get it wrong at any stage. But I'm sure that most of us are busy teaching patterns and sequences to grade 12s at the moment and heading for Euclidean geometry soon, and then into grade 11 and ultimately in grade 10. What I noticed that the Gauteng did, which I was very excited about, was to devote an entire week to quadrilaterals in grade 11. Prior to analytical geometry, quadrilaterals is, of course, essential in analytical geometry, but it is a major part in Euclidean geometry, and I feel therefore justified in giving it a bit of attention today. The latest research and diagnostic reports that are available are for 2020, as we anticipate the results for the 2021 exam. But I thought that it would be nice to just have a record of this research over the past 8 years since CAP started in 2014, very brief, but nonetheless just an idea of where we are. And so that as we await the 2021 report, which we'll receive probably in the next month or two, we have some sort of background against which to compare these and look forward to them. So the average over 7 years from 2014 to 2020 saw Euclidean geometry placed third in the topics in paper 2. Last year, however, Euclidean geometry came off quite badly as number 4. So who knows what is going to happen in 2021? I think that the Euclidean geometry from the 2021 exam was quite challenging, so who knows? What is interesting here is that the average marks achieved for paper 1 and paper 2 don't really differ very much. People always come out afterwards and say which was better, 1 or 2, and there's always this difference of opinion. And now we can see why. It's more or less even. A very important comment I want to make, because I'm sure that to you also these marks look quite high to what I think in reality they maybe are as national averages. It is important that this has been compiled on random samples of candidates, so they do not necessarily reflect the national averages accurately. However, it is useful in assessing the relative degrees of each question, and most importantly, as experienced by candidates. And in that sense, these results and numbers have been very consistent, and so I feel very reliable. Very interesting is the question performance per question graph that we get given in a diagnostic report, and all looks quite reasonable for 2020 there, with only a trig question dipping below 40%. But I really encourage you to actually study more carefully the per sub-question diagram, where we see quite a different story, and we see quite a lot of big problems all throughout, and particularly in the 2 topics of geometry and trigonometry. So I'm leaving it at that for the research for the moment, other than the diagnostic report. So what happened in 2020 that we did not perform so well? Again, here, this is just a valuable document. We all get the diagnostic reports, and we know we should read them, but I just thought I'd make it easier in preparation to see what it is that learners are doing quite commonly. And as we look forward to the diagnostic report of 2021, notice if there are going to be any changes or any of the recommendations and errors and misconceptions that are reflected in the reports that appear then. So each question, I have the common errors and misconceptions right next door, followed by a slide where the full memo is provided. And again, and so on. And then at the end of each question, the overall suggestions for improvement. And of course, this one here, teachers must cover the basic work thoroughly, which is very much what I have borne in mind in this presentation today. So the diagnostic reports, very good to study, and as I say, to look forward to when we get the 21 diagnostic reports. The grade 10 to 12 exemplar geometry, for anyone who's listened to anything I've had to say in the past will know that these are my favorites because they offer us a very quick and easy look back over our shoulder. When we're looking at a grade 12 class, what do they remember from grade 10, grade 11? And even if it's just done in a diagnostic kind of way, to go and look at these two questions from the grade 10 exam, the full solutions are provided. Seeing words like kite, matrix, I've seemed to have forgotten what a kite is, parallelograms, proving parallel lines, proving a parallelogram. Do they still know there are 5 ways in which we can do that? And that these two both constitute an understanding of converse theorems, which is a major challenge in all of geometry. The grade 11 questions, also we can pick up the clues that we will speak of, the triggers for various theorems, and again, more converse theorems that come up, and proving a line, a tangent, proving parallel lines, proving a cyclic quad. And then the grade 12 itself, to start working on that, because considering the fact that actually 2/3 of the exam consists of grade 11 work, so again, just a whole clatter of converse theorems lined up for us. And just a nice little reminder that the integration of topics is to be expected, as was very clearly set out in this exemplar exam, and all the memos there. So just a very quick little acronym, ACT, as a brief problem-solving piece of advice. Be active, get going. I can remember teaching a lesson once upon a time, and about a week later, this Benjamin came back and said, Mrs. Edie, I'm afraid all I see is lines. And so it's very much formed my approach to the teaching of geometry and what we should be doing. And what do we mean by being active? We mean get cracking there and have a look at clues and triggers to theorems that we know. Recall that theory systematically. There is a huge body of theory, but if we recall it and categorize it and do so systematically, that is so important. The curriculum documents are there just for your convenience. They are good to look at. And then, of course, the theorem statements and acceptable reasons. It's just very nice to just have that very at hand, and also perhaps to make sure that your learners have them. It's just a very safe habit to get into as they prepare for their matric exams at the end of the year. The circles have little sketches next to them. Jenny Campbell did that as a useful way of finding all those theorems much more easily. And we've also divided the theorems up into the groups, which you will see in a while as well. And some important advice to pass on to your matriculants. So that is the first booklet. I love the quote from the philosopher Immanuel Kant, 18th century. Theory without practice is empty. Practice without theory is blind. And that is the background of what I'm about to present. And so if you find that I'm doing a lot of theory, please understand that I really believe in this. So what is the content framework in geometry? We really just deal with lines, triangles, quadrilaterals, and circles. And I think as simple as that is, I think it is very important for learners to know that there are these different shapes that encourage them to look out for different categories of things. And the important thing to note here is that lines, triangles, quadrilaterals, and of course the angles involved and sides are all dealt with by grade 10. Circles in grade 11. So what is left for grade 12? The theorem of Pythagoras, which they did in grade 8, similar triangles, which they did in grade 9, the midpoint theorem, which I put there in grey, which they did in grade 10, and I've yet to meet a matriculant who admits to ever having been taught that theorem. And it, of course, being a special case of the proportion theorem. So the proportion theorem is not entirely an unfamiliar situation. Certainly one's approach to examples in the midpoint theorem, it's very similar to the approach that what we will have in the proportion theorem. And the necessary revision for that is ratio, I think from the junior school, proportion, and area of triangles. So that in a very short summary is the content framework for geometry, around which we will do the rest. So can we remember what to know about lines? And the first thing that I want to really focus on, as I mentioned earlier, is that vocabulary first, and then the facts. So let's first of all just look at the two situations, which obviously everyone is very familiar with. But as teachers, I would like us to make use of the opportunity of, first of all, emphasizing the fact that it's the vocabulary that counts first. So the fact that these lines are not parallel is very deliberate, because the focus should first be on naming the relationship between that family of angles and this family of angles, between naming adjacent and vertically opposite angles, before talking about any facts that we have about those. And in these very first two facts that any learner ever learns in geometry, we have the opportunity in the very first one to hear about a converse statement. If angles are adjacent, then what? We know that if two angles are adjacent, then they add up to 180 degrees. So we can be introduced to a converse statement right from the very beginning. And then logic. Does a matriculant know why vertically opposite angles are equal? I think that every single statement in geometry, every learner should be able to prove and know why. It will just make them so much more comfortable in the territory. And then, of course, we all know the facts over here, and that it is yet another opportunity for the converse statement. If the lines are parallel, then 1, 2, 3. If 1 or 2 or 3, then the lines are parallel is the converse statement. So we really, it's so important to begin what has become quite a problematic concept, namely converse theorems, to begin them with these really simple ones. I have had summaries for ages on circles and quadrilaterals, but I've never thought to make a summary on triangles. And I thought, you know, if you were to perhaps just think about it right now, how many would you be able to write down and not leave out any? And maybe you wouldn't, but your learners. Are your matrics aware of the rich amount of material they learnt about triangles? So I tried to make my first summary of it. It's not very polished, but it looks like this. And I thought I'd group the sum of the interior with the exterior, then isosceles, equilateral, and right-angled triangles. And if you see these red asterisks, these are all the opportunities where there are converse statements. Area of a triangle and related facts. Similar triangles and congruent triangles, and we know how often learners in matric confuse those, especially the symbols. Midpoint theorem, also involving all of these, those, as I say, marked with the asterisk, involving converse theorems. So there are about, actually, if you include these related facts on area, there are about a dozen facts in triangles. And I feel that we should enable learners to readily think of them. I'm sorry about the look of this, and I will make amends shortly to break it up. Could I ask you to just focus on the grey arrows for now? And see it will explain the logic behind this mass of information, which we will break down. So for now, the grey arrows show us how to go from a quad to a trapezium, to a parallelogram, to a rectangle, ending up with a square. Or we could have specialized from a parallelogram to a rhombus, and from there got to the square. Or we could have done the progression in a completely different route, gone from the quadrilateral to the kite, and thereafter to the rhombus and the square. And the importance of this progression is that it underpins all the understanding and logic required, so that never again need a learner ever learn a list, for example, of properties or of definitions. Everything will actually be extremely logical, and once that logic is understood, there will be nothing left to memorize, just to know. The summary of circle geometry theorems. There's the center group, the no center group, where if we don't have a center or a cyclic chord or a tangent, what do we do? Same segment theorem or equal chords. Then the cyclic quad group, there are 3, and the tangent group, there are 2, along with the extra fact that equal tangents from a point are equal. And then it highlights the fact that we often miss out on the equal tangents concept, the equal chords, the equal radii even. The smartest of matriculants have walked out of the exam having failed to notice and use equal radii, base angles of an isosceles, all these really elementary things. And that is the challenge of geometry, is to keep as fresh in one's mind when you're in matric the facts that you learnt in grade 8, 9, 10, and 11. So as one looks at this summary, what is the value of it? Well, the value of it is definitely, if one looks at the situation in an example, if it has a center, then that is the group we think of, and so on and so on. So as far as recalling, it is very helpful to collect over a dozen facts in a very systematic and effective way. But the other way of looking at this is to present it to your learners and say, okay, these are all the statements. Can you prove them all? Don't just think about the ones that are examinable. They should be able to prove every single statement that is here, and then to try and see how all those theorems are actually linked and how we use some to prove others. And we will come across that later. We come into the booklet 2, which is on lines, angles, triangles, and quadrilaterals. And I'm obviously not going to spend a lot of time on this, but I would like you to actually offer your learners the opportunity. If you see that the bulk of the content of the framework that we saw earlier actually comes from these 3 years, this little 20-page booklet will offer everything they need to know. So anyone who's thinking, oh, we just don't have time when it comes to grade 12, well, I've shown you how little there really ought to be left to be done in grade 12 if all of this is already under control. So in this booklet, there would be lines and angles, always vocabulary first before facts, as so for triangles, quadrilaterals, and of course the midpoint theorem, followed by exercises on each of these 4 areas and full solutions on all 4 sections. So I really would like to ask that you consider giving this to your learners and offer them. They can do this on their own because every single question has a full solution for them to check their own work and their own progress and their own knowledge. And this is how it goes. So this is not one of those places that I'm going to roll through because you don't need to get the details from me right now. But I promised you I would make amends for this summary and just talk a little bit about because quadrilaterals is actually a very big section. And the fact that we can link it just makes such sense. We need to know the difference between defining quadrilaterals and observing properties of quadrilaterals. We need to observe this progression below in thinking about the definitions so that the definitions make sense. We need to observe that progression in order to consider the sides of the various quadrilaterals. Are they parallel? Are they equal? The angles. Are they equal, supplementary, or right angles? And then, of course, the very, very amazing investigation that can be done using diagonals. It completely opens up a massive understanding and experience of the theory of quadrilaterals. So investigating diagonals, it's lovely. One can also work out and go into the polygon with n sides and investigate the patterns in algebra here that one can play around with and get a little bit of extension into algebra, which is always necessary. And then the trapezium. We start off there with the area of a trapezium. Traditionally, this comes up often in analytical geometry, and learners do not know the area of a trapezium, and probably because they don't know why. And since the proof is so very easy, once they've seen the proof, they won't ever forget this very nice formula that rolls off the tongue, half the sum of the parallel sides times the distance between them. And then can you derive a formula for the area of a kite? The fact that the area of a kite is half the product of the diagonals is not common knowledge to matrics, but again, a very easy one to prove. Having observed the progression of the quadrilaterals, could this formula apply to a rhombus and to a square is our question. And now, drawing in a second diagonal, we get all those properties of the diagonals in a parallelogram, a rectangle, and a square, kite, and a rhombus. And the questions, do they bisect one another? And I have given a slide with all the answers. Intersect at right angles? Do they bisect the angles of the quad? Are they equal? And all those aspects. So I don't mind now giving a summary of the diagonals because I hate summaries of facts which are not understood. But hopefully these facts will have been understood once they've been derived and once one's learners have been encouraged to derive them themselves. I think area deserves a very special focus because it definitely is not an area where learners are confident in grade 12, and that we just take that out of that cluttered summary and just focus on area for a bit. These are all details about theorems and areas and the possible assignments that you can do. And then these are the exercises and solutions on all 4 of those sections. We now get to circle geometry. And again, start with the language. I think that language is extremely important. Always, as I said, groups 1 and 2, we know, of course, those very obvious ones. But when it comes to arcs, major arcs, minor arcs, major segments, minor segments, and not to mention the word subtend, for many a learner, the road along circle geometry comes to an abrupt end when they don't understand the concept of the subtending of an angle, either at the center or at the circumference. So that's really important to do that properly. In this most recent exam, the definition of a cyclic quadrilateral, I think we had an example over here of AOCB being claimed as a cyclic quadrilateral, and it really just required a simple definition to know and not make that error. Exterior angle of a triangle was often confused, and now we get the exterior angle of a cyclic quad, and it has to have the produced of a side of the polygon. And then a tangent, which often is just described as a line touching the circle, which we must realize is a tangent, versus the secant. The summary that we had a moment ago, and how are we going to link them? I'm going to pause for a moment, and you can perhaps just look at those grey arrows, and if anybody has any comment or any question or observation that they would like to make, please feel free to do so, unless you're too busy concentrating on where all those grey arrows are going and from where they're going to where. Because I love to let learners loose on using just those grey arrows to derive all those theorems for themselves. These are the formal proofs. As you know, there's been a second one included over here as from a year ago. I've got that over here. And there are many learners, I don't know about many, there are learners who don't mind learning theorems. Perhaps there aren't many. But some are more conversant and okay with text, while others are not. So this is the 2 methods for the tan chord theorem over here. And unfortunately, what happens is that most learners end up memorizing them the night before the exam. And that has 2 very real problems for me. The first thing is that they have denied themselves the opportunity, the key to logic, which underpins this entire module. But they've also now cluttered their brains with something that they don't really understand, and it puts them on a very bad foot. I think they must own their own brain from the beginning. So for those who have a problem with text, I've offered this in the help in proving of theorems, visualization. And my challenge to a learner would be, okay, this is your situation. You would like to prove that this angle at the center is double the angle at the circumference. Follow through these next 3 sketches. And when we've done that, I want you to come back and close your eyes and see if you can envisage each one without looking. So the first one is the construction, which just, by the way, is somehow a problem for learners to make a construction, but one can prove every single circle geometry theorem by drawing 1 or 2 radii. So that's really important. Okay, so envisage that line there. Envisage the 2 isosceles triangles with equal base angles. Envisage the 2 exterior angles of the triangle. And then we observe that that angle at the center is double x plus y, which is the angle over there. And seeing that those steps enables learners to think the logic. And it's lovely to see them try it. And of course, over here again, I've got it for the similar thing for the opposite angles. I've also done this for every single theorem, not just those that need to be examined or that will be examined, but also for others, because I just feel if visualization is something that will help, and I would love feedback from you on this, to let me know if it's working, because otherwise, I would love to know. I really do believe that it is so much easier for learners. And then when they've done this process, ask them then to go and write out the proof without looking at the written one that has been given. They can then go and check their proof, maybe to check that they've got all the steps, to check that they've got the acceptable reasons for every step that they should have. So over here, the theorem proofs, visual presentation, and first of all, I'm giving the examinable ones. In each case, giving the situation first, and then the construction, which you can see here is the radii, the logic is the congruency, and then the final fact, and followed by the statement of the theorem. I just think that these make the actual statements very much more convincing. We've done those 2 already, and then there are the 2 different ways that we can prove the tan chord theorem. I like the first one because it is also the construction of radii. Over here, that is quite a difficult construction, and as was experienced in this most recent exam, I think learners got asked this example from the other way, that the angle x was on this side and they had to go the other way, and they'd learned it from this side, not that side. And if they just learned to say, and similarly, it can be proved. And I'm afraid if they didn't do that, or if they didn't get it right working from the given angle, then there was what is called a breakdown, resulting in no marks. Further theorem proofs, visual presentations, even of ones, as I said, that are not examinable, as well as the one of tangents from a common point are equal. There are 2 different ways of doing that. And it's just the experience of going through a different construction for these 2 that makes one, forced to then apply other theorems that one has learned in circle geometry, and how they can be used to prove further facts. This over here is an excellent example in geometry, and it's all very tiny because this is what the booklet is going to look like that you will receive to share with your learners. And what I like about this is it's got so much going on. It's got all the theorems, it's got a center, it's got a cyclic quad. It doesn't have a tangent though. And deliberately in our material in TAS, we don't include tangents at the start. We make sure that learners get very comfortable with the first 3 groups of theorems before embarking on including tangents in their thinking. All the detail over here that we've talked about. The 2018, I think, was the first year where there was really a flood of converse theorems, so I thought just to include that. It's the only set here where I don't include the solutions. Obviously, it is included in our toolkit, which I don't know if you know about, grade 12 maths toolkit, which has got all the IB and DBE exams of the past since 2014 for the DBE and 2017 for the IB. Just some great examples. This is one of my favorites because now this one again has nothing. It has no center. It has no given cyclic quad. So now what do we do? I would love to pause and give you time, but I really don't want to run out of time. And if you want to come back to this, but it is really an exciting one. And of course, I can't help just commenting what it does have is the same segment angle right here at B equal to angle P1. And it's upside down. Learners hate a thing to be upside down. And we often advise them, turn your drawing round and round until you do see. Is there a question being asked there by Delene? And then plenty of worked examples are included for learners to get really strong on circle geometry. So proportionality, similarity, and the theorem of Pythagoras. As we said, ratio and proportion, we have to really make sure that learners understand that. And they would, of course, need to be reminded that they've dealt with ratio all the time in trigonometry, since that is what sine, cosine, and tan are, is ratios. And then the link between what proportion is as being two ratios equal to each other, and the relations that one can do with that. The proportion theorem. Now, as opposed to the circle geometry, the proportion theorem has only one statement. So it has different challenges, but is so much simpler than to work with circle geometry because of the great number of facts that we have to have. And the strength of the proportion theorem work is that one can just focus on the one statement and, of course, its converse. So very nice and easy, simple examples are given here. And worked example 3, the learner that came back to me and said, Mrs. Edie, all I see is lines, is what I think of when I see this example as well. So what we have to do with proportion theorem is very, very simple. We just have to find the triangles in which we can say this one thing. So how many triangles do we have in this drawing? We have triangle DAB, we have triangle DAC, and we have triangle DBC, and various pairs of parallel lines. And applications of the proportion theorem, as well as the converse of the proportion theorem. In worked example 4, again, we have a great picture, again having to identify triangles. They are definitely here and easily to see, two triangles with parallel lines, but this triangle on the left here, ABC, there are no parallel lines. But what about the ratios of the sides? 3x to 2x, 12y to 8y. So both of them have the ratio 3 to 2. And applying the converse theorem, we get the fact that FG is parallel to BC. Whereas clearly here, where we have to prove a proportion, we are using the original statement. So in studying and analyzing the diagram, this advice is really important, as we've discussed. A very, very good example to share with your learners. Then we never start the proof of the proportion theorem with any optimism before revising these two very important facts on the area of triangles. I must say, I can't find any requirement for the areas of triangles to be studied in earlier grades. Maybe I've just missed it, but generally they don't know that triangles which lie between the same parallel lines are equal in area and on the same base have equal areas. And triangles which have the same height, their areas have the same ratio as their bases. And those two concepts, once they are understood, then this proof is incredibly easy and so comfortable, whereas it looks very complicated. I've again given the visual presentation, which I'm not going to keep going through with you. You can use them if you find them useful for your learners. And then for both proportion theorem and similarity, there's an exercise with full solutions provided for practice, because of course the practice and the application is crucial. The definition of similarity. Similarity of polygons insists that there be two conditions obeyed. The polygons must be equiangular and their corresponding sides must be in proportion. And what we learn in grade 9 and grade 12, perhaps not in grade 9 as clearly, is that the one condition implies the other in the case of triangles only. And so A implies B in the original theorem, and in the converse theorem, B will imply A. So both the theorem and its converse have the ultimate result. Therefore, the triangles are similar, because in the theorem, it is proved that equiangular triangles yield proportional sides, and then the converse is the other way around. But in both cases, the result and the conclusion is the same. Here's some lovely worked examples here. And of course, this vital thing about the numbering of the triangles If the triangles get numbered according to their equal angles, then one doesn't have to look at the drawing again to just write down the proportion, and it makes life so much simpler. Similar triangles and proportion theorem are often confused, and there are some incredible examples of this, but I thought that this would be a nice example to say, find x first, and what will you use for that? And what will you use if you're looking for y? To make it very clear that the proportion theorem involves those two sides that are being divided by the line DE, and that we use proportion theorem to find x over 15 equals 8 over 12. But when we need to find y, a very common error, I don't even want to say, I think you all know what I'm saying, that instead of saying y over 30 is equal to 12 over 20, there's a bit of a habit of just going, it's equal to 12 over 8, but I've never said that. So it's important that we can distinguish between the applications of these two. There is one more example that we will be looking at, which makes this all the clearer. So as far as the proofs are concerned, I think it's a tricky proof, but I've broken it up into 4 stages. And it's quite a nice way for learners to be able to describe and say, okay, in stage 1, I prove congruency. I then follow it with corresponding angles, which gives me parallel lines, from which I can then, according to the proportion theorem, write down proportions. So there's some kind of logic in just a description, a word description, as opposed to a detailed geometric step-by-step, which can make it easier to learn. I would like to just comment that people are often asking, do they have to learn the proof of the converse? My answer to that is that this proof is not listed as examinable in the 2021 exam guidelines, and I'm choosing to listen to that in my answer to you. It is, however, listed in the CAPS curriculum, and that is why I have included it here. Otherwise, I probably would not have, because it's excessive, and you can obviously give it to your eager beavers. The visualization of the similar triangles proof is there, and the example that I've been promising. This one over here, which involves, obviously, there's a circle with a center, there's a midpoint of a chord, and a resulting right angle over there, and we have to prove parallel lines, which is asking us, why is OV perpendicular? So they kind of introduce or pulling us into that. And then we have to prove the parallel lines, and after that, we have to prove that TMNS is a cyclic quad. And a reminder of how we're using our strategy on circles to say that there are 3 ways that we can prove that that is a cyclic quadrilateral. And it is not a limitless thing, which is very comforting to know. I don't have to actually think of a million things. I'm only going to try 3 different things. But as you've been looking at this, I don't know what else is coming to your mind. If you look at part 3 here, OS.MN equals twice ON times WS, which is a grade 12 question. And one look at that figure certainly makes me think that it's proportion theorem that I'm going to be needing. But if you go and take all 4 of those sides and you mark them on the sketch, as I'm showing over here, you mark them on the sketch, it becomes very clear that it is not proportion theorem, that it is in fact going to be similar triangles that are going to be needed. So the more examples that we can actually find, which are actually confusing to start off with, they just end up making us understand the concept more and more. The theorem of Pythagoras, also not listed as examinable in the 2021 exam guidelines. This is very, very important advice for problem solving. For learners it's not too much to study there. There's obviously the order of the lettering. There's the confusion with the proportion theorem. So a summary of a lot of the problems that do appear in learners' work in similar triangles, the exercise and the answers, which I said would be there. Of course, very important is to send your learners off for further practice in the grade 12 Maths 2-in-1, or the grade 11 work is actually offered and included in that book, and the circle geometry is extensive. The new section on challenging questions, of course, is very, very appropriate for learners to advance into on the geometry. Just to say that all these geometry materials, booklets 1 to 4, were created and produced by us to support the teaching and learning of geometry in high schools in South Africa. I think I can say that I have had a dream in my life of geometry being the favorite topic for all teachers and learners. And so whatever I can offer, or we can offer as a team, we are only too happy to do. So these are all freely available to anyone who wishes to use them. I just do need to add that it may not be sold via any channel or used for profit making of any kind. Was it necessary even for me to say so? So just now, to end off, I would like us just to cast an eye on this most recent exam that was written, because any day now we're going to be getting the reports on this exam, and to just have a look at these slides and then share them with one's learners as you know, as you discuss the circle geometry, for example. And what do you see? So clearly here we see a cyclic quad, and we see two tangents. And those are our triggers, which I've put in bold over there, and they define the situations for us, and then it makes it very easy for us to see what to use. There is no center, however, so we can discard group 1 completely. There's no subtending, we can discard the second group completely. So it's very nice to see that one can just need to focus on 2 groups, the third and the fourth group. Each example that is given, by the way, this one is without the memo, if you want to share this with your learners, first of all, so that they don't get the one with the memo first. All of these questions have been offered with the drawing, and then after that, the memo. So this drawing seems to have, okay, there we go. So this question 10, over here we do have a center. We have quite a lot going on here. As you can see, we have diameters, not just one, but 2 of them. And believe it or not, recognizing that they were equal in length was a crucial part of this proof, which I'm sure many people were frustrated at not having kind of realized. There's the center and all that brings up. There's the angle of 90 degrees here. So we spot our very first circle theorem as to AF being equal to FE. And I presume all of you did try this. And we're not having a face-to-face, so you won't have to put up your hand if it didn't occur to you that the midpoint theorem was pretty key in the solution of this particular example. F being the midpoint of EA and M the midpoint of the diameter. And applying the midpoint theorem in triangle EAB was most unexpected. So we do need to have all the geometry from all the grades uppermost in our minds to be successful. In order to prove that AD is a tangent to the circle that passes through, the question always says that passes through A, C, and F, it is always useful to draw that little circle through A, C, and F, and to bold what is now the line you're meant to be proving is a tangent. And then suddenly you can very easily see that the tan chord, the converse of the tan chord theorem can be used here to prove that A2 is equal to angle C. It so happens that we are also able to prove using the fact that this line is perpendicular to the diameter AC of this triangle. So in fact, both options could have been used in the memo to that particular question. Question tips. And if one has a look to see that geometry counts 40 marks, and this question over here is 13, and question 11 was, I'm skipping through this here, question 11 was pretty busy. It's not going to have been easy for learners, the majority, to have scored particularly high. So I've put this drawing over here just so that you can play around with your learners and one time put your X there and get them to prove it, then with the one construction, then with the other, and the other time put your X there, so that the logic and the playing around becomes something which is fun and not something which causes stress when something is suddenly offered the wrong way round. So again, our clues here is that we have a tangent and we have parallel lines. And apart from the tan chord. I actually looked at this and thought, well, I can see K1 is the, for the tan chord angle equals L1. Oh, and I was very proud. I could see PKS is equal to the whole of grade, the angle at L, angle KLS, to name correctly. And I didn't at first notice that, of course, that one is there too, between the tangent and that chord. So geometry is just such a fascinating topic in so many ways. As soon as you think that you're on your way, there's something more to learn. And then we have to prove the cyclic quadrilateral, we have to prove similar triangles, and it's very busy. And I think all of you can over here spot your parallel lines. And when we see parallel lines, we must know we have to think of the straight line geometry of parallel lines, which is coming in here. We'll use the corresponding angles, S1 equaling angle NML, but also it should remind us of the proportion theorem. And the last little thing I wanted to mention here is how important it is for learners to know that invariably each little question that one is asked leads to the next and to the next and to the next, which is not something that they easily think of. I've got a few documents here about TAS, which I'm not needing to go through with you right now. You can go through it at your leisure. But just to say that the Grade 12 Maths 2-in-1 offers a unique question and answer method of mastering maths, and that all our products aim to develop conceptual understanding, procedural fluency and adaptability, reasoning techniques, and a variety of strategies for problem solving. Gretel, over to you.
Sure. Thank you so much for an incredible presentation. I am hearing an echo. I just want to check that it's only on my side. Is that good? Okay. Am I clear to go? Can I get a thumbs up? All right. Such guidance through a section of maths, and that I think is safe to say has been cause of many headaches for a lot of teachers and a lot of learners. So thank you for sharing your passion with us today, as well as your belief that geometry is possible and can even be fun. So yeah, thank you for that. As I mentioned earlier, Susan and Jenny are now going to share a little bit more about our support program with us. So over to Susan.
Yes, hi. We've just been through the most incredible webinar, and we will be getting the course materials that will support your teaching. What we now have for you is a microcourse, which consists of videos and quizzes. In the videos, we work through geometry questions, but not just giving solutions. We try to explain the thought process behind how you approach each problem and how you can help your learners when you teach them. In these videos, we suggest you pause after seeing each question so that you can do it yourself, and then watch the video to compare our solutions to your answers. One beautiful thing about geometry is that often there are many different ways to do a question. One way might be brute force, another way very elegant. It is essential for our learners that they are exposed to multiple ways of being able to do geometry. There is a place for all solutions. The succinct ones are beautiful, but many times it is only through sheer determination and tenacity that we can find a solution. This course is not quick. Spend time working on it, as I guarantee you that you will get something out of it, whether you are just starting your teaching career or you have many years behind you. Listening to somebody else teach is often invaluable. It either reinforces what you are doing, or it gives you ideas as to alternative approaches. I know my teaching changed a bit last year as a result of seeing Jenny's videos. We can learn so much from each other, and if you have approaches that you use that work well, please share them with us. We hope this course will deepen your understanding, which in turn will help your learners to understand more fully. Good luck as you journey through this course. Thanks, Gretz.
Thanks, Susan. And just to double check if Jenny wants to add anything to a little bit about the package, including the micro course. Jen?
Hi, great, thanks. I don't have a lot to say, which is unusual. I just know that we had a lot of fun finding questions that we thought would cover quite a broad spectrum. And there were a couple of times when I was going through the videos that I actually had to stop and start again because I'd forgotten what I had to do because they're not easy. So we started from very simple questions and then we gave you some quite challenging ones to think about. So I strongly recommend that you use them for yourself if you're new to teaching geometry, and if you're not, then give them to your learners as extra backup to what we're doing. And we really would value your input. If you don't like something, the best thing to do is to criticize it so it comes out better next time. So if you do have time to work through the videos, or if you let your learners loose on them, please give us feedback so that we know what we're doing right, and more importantly, we know what we're doing wrong. Yeah, we're passionate about what we do, and you're passionate because only crazy teachers would be in here for just over an hour after teaching school. So I'm very impressed with all of you, and I've no doubt that you're doing a great job in the classroom. Thanks, Reds.
Thanks, Jane. And yeah, and Susan, I'm sure that has whet your appetites nicely to go and get a little bit curious as to what these micro courses are all about. So we thought at this point to briefly share our maths teacher support page on our website, which I'm going to share with you now, just to kind of navigate our way through there a little bit. So if you can have a look and see here, the teacher tab at the top takes you to the free ebooks that I mentioned in the beginning. The URL for our website is theanswer.co.za, which I see our team, Sammy, thank you, has posted in the chat. But yeah, it's just quite easy to navigate once you know where to go. There is a teachers tab, the free ebooks. Maybe I must just click on it and show that it comes up. It takes you through how to access your ebooks, especially for the teachers. And if we go back to the teachers tab, there's a click through here for free grade 12 math support. And on this page, which is where you hopefully will spend quite a lot of time and coming to check in what is currently live, what is coming soon, and you can click here to join through to whatever you're interested in. As you can see here, for those who didn't know about this button, you could have clicked through to today's webinar by clicking on that attend webinar button. This image is also clickable through to the 2022 full year program. In there, which I'm going to click through to, there are provisional dates, and you'll see at the moment, term 1, we've had patterns and sequences running live already. Euclidean geometry, our webinars today, videos are available from today. They are up and running already. So go for it and keep an eye on this space. And as I say, things will be clickable and you'll be able to find your way quite easily. If you would like to know a little bit more about the program, there is a click through here as well, which you may have received via email already, so it may be familiar, but you can learn and read up more over there. So Jane, again, I don't know if there's anything there that you would like to highlight while we are on with the website, or Susan or Mum.
I think the most important thing is to just realize that we've got stuff to support you all the way through. So if in doubt, just hit the website and look for something. And if you happen to be sick or down for the day, then give your learners videos to work through. Or if you have a child who's sick and they want you to do special stuff for them, refer them to the video, because we've covered the entire syllabus with each separate batch of videos. So if they go through the videos, they will still need to do more practice independently, there's no doubt, but they are useful for independent learning. They're useful for when you can't be in the classroom. They're useful for when the child can't be in the classroom. And given that, plus the free ebooks, you have incredible resources at your disposal, because this is another year that's even more challenging. Given that this group of grade 12s now has had a disrupted grade 10 and a disrupted grade 11, the challenges are even greater on you and on your kids than they were on last year's matrics or the year before that. So we're very aware of that, hence our attempted outreach. And then we've got the math support group where teachers are helping teachers. So if you are stuck, you're trying to share things with each other, please make use of our WhatsApp group, and you can email me whenever you need help. Yeah, that's all I have. Thanks, Grace.
Thanks, Jane. And right, so Then, as I mentioned earlier, we'd be posting a link into the chat about a feedback form for today's webinar. And you'll see, thank you, Sammy, there it is in the chat for you to click through and fill in. It'll just take a moment, and yeah, if you do that, it would be much appreciated, but also definitely worth your while, because once we have your details from the form, we can then send you the recording of today's webinar, a link to all the downloadable booklets that Anne was working through, and as well as other relevant and useful links that you will be able to refer back to and use. You will notice also on the feedback form, there is an option to select to be invited to our TAS Maths Teachers Support WhatsApp group. So we'd love to have you be a part of this community. So please, if you could submit your forms, then we can include you in it. While we give you a moment to do this, you're welcome to think maybe if there's anything you would like to ask, pop your questions in the chat or just have them ready. And when we follow shortly with the Q&A session, then you'll be able to come off your mic and speak. Just to check that everyone's having success clicking through to the link of the feedback form. If you are having trouble, sometimes it helps to copy the link and paste it into your browser, and that should work as well.
Chanel and Stephen both have a hand up.
Chanel, you okay, go for it.
Yeah. Thank you. I don't have a way to get to the chat box, so I'm not able to access the link. I've got no idea where to find it. So is it possible to email that to or not? I don't know how to get to there.
Okay, just a practical question. Have you got your Teams open fully on your screen in Max? So not minimized or not kind of, is it open in full?
I believe, I mean, I can see that, you know, like my mic and that, and then open share tray, and then there's dot with more action, but nowhere can I see enter full screen. Maybe it's that one. I still can't find the chat box.
Okay.
There's a hand and they show the participants, and my more actions has keypad, exit full screen, show call details, but I don't have a chat box.
I'll tell you what I'm going to do. I'm going to stop sharing for a moment and see if it comes up, because sometimes that makes a difference. Any luck?
I don't know. I just don't have it. I don't know where it is. I must be doing something not clever.
Not a problem. Can I ask that you take down Jenny's email address? It is jenny@theanswerseries.co.za.
Jenny, Jenny?
Correct, yeah.
Okay.
And then if you pop her an email, Jen, is that fine? And then Chanel can be.
Yeah, I'll send the feedback form to you if you give me your email so that I can connect with you, and then you're back on track.
Thank you very much.
Thanks for connecting. That's very impressive effort there.
Yeah.
I enjoy your teachings. Thank you.
Great. Thanks, Chanel. Thanks for that feedback. And thanks for making the effort to get the feedback form. And
I had exactly the same problem.
Oh, okay. So you've got Jenny's email, jenny@theanswerseries.co.za. Please just pop her an email. Apologies for this. I think Teams is just so different on all the different devices and its different forms. So we're learning each time we work with it.
Sorry, I just want to make something clear. I'm getting a zillion emails because people are joining our group, which is awesome. So the people who want the link, if you can just make the header video link.
Subject,
so that I know that I'm sending a link to you for the recording. Otherwise, you're going to get yourself into a WhatsApp group you probably don't want to be on, or I'm not sure, but if you're joining the group or wanting a link, if you can please just specify. If your emails already come through, I'll know it's for the group. But if you're sending an email now for a link, please specify that. Thanks.
Okay. So I think unless there are any queries, I'm happy to post the link again. Please shout if anyone would like the link posted again. I think if you are ready for our Q&A session, Jenny and Susan and Anne, if you guys can start getting yourselves ready for that. I just want to say first a big thank you to each of you that have attended today for joining us. And we really value all your input and contributions, both during the webinar and in your feedback. And for those who would like to stay on for questions now, we are going to head into the Q&As shortly. You're welcome to stay as long as you can. So please, please do that and don't hesitate to ask your questions. So yeah, all the best to each of you for teaching this incredible section of maths and wishing you all a fantastic first term. So go well, everyone. I might come on again at the end, but it's been a pleasure to host you today, and I will hand over to my team for Q&As. And I think I'm going to introduce to the Q&A session just by picking up on the comments that came through from some of the teachers regarding the refreshing approach to teaching theorems. And I wondered if any of the teachers that commented would like to say more about what it's got them thinking, or if anyone else had something they wanted to share. So maybe that can go to you, Anne or Mum, first, and we can take it from there. There is a hand up, so let me just manage. Chanel, are you still with a question? I just want to double check that your hand up, is that still from earlier?
Can you just repeat the email? Sorry,
Yes, sure.
It's Jenny at?
Yeah, Jenny at, then it's theanswerseries.co.za. So all one word.
Okay, I think I got it right. Thank you so much.
No problem. Okay.
Thank you.
Pleasure. Go well. And then Reika, I'm not too sure how to say your name, but you're welcome to ask your question. Just make sure you take yourself off mute before you start speaking.
Oh, yes, ma'am.
Yeah, there we go.
Thank you for the session. It was very helpful. I'm looking forward to being part of the group so that I can learn more. Regality is the name of the school. Thank you.
Wonderful, thank you. And I wonder if our maths team doesn't want to all come on camera so that we can all be present for these and respond to those that are brave to share their questions and feedback.
If I can just mention something with the WhatsApp group, I posted a challenging problem in patterns and sequences today, and a whole lot of people then posted solutions, and there was quite a nice lot of chat that was going. So that's what we're going to be doing at the WhatsApp group, is we are going to be posting challenging questions every so often, just to keep the interest going, and well, just to give all of us a challenge at some stage. So those of you on the WhatsApp group, if you have any challenging questions, feel free to post them for us as well.
Yeah, and when you post the questions, if you don't want to have to draw a complicated diagram, if it's from a past paper, you can tell us the paper and the question number, and we can look the sketch up ourselves. But yeah, it's going to be interesting with geometry. You can also take a photograph of what you want to post. So there are different ways of communicating, which is why WhatsApp is great. I just wanted to say, Anne, that was amazing. I think all of us wish we could actually have known what you know and what we know now. If we could have known that before, we would have done a better job, and maybe we'll see a significant jump in the percentage result. If we filter out what we learned today to all the colleagues that we work with and all the colleagues that they work with, and we start a ripple effect, it's a little bit like dropping a stone in a pond. So there's so much power that we share with each other to cause a massive ripple effect. It's super exciting, and I hope you're all feeling very excited as well. kids do struggle, but when you're passionate and confident, it definitely grows passion and confidence in children.
Thank you, Jenny. My comment that I would like to make is that I've been so excited with the attendance, and as we air our various products, which we worked on last year, be they videos, be they webinars, be they whatever, we completely and utterly rely on your feedback and you know, any advice that you have for us or requests or whatever. And the other thing I'd like to say is that I'm just so excited to be having this incredible team. My daughter Gretel, and then Jenny and Susan, who have joined us in the past year. We've somehow always been connected and done a lot of work together, but now we are actually the Maths TAS team, and it is so vibrant and just so exciting. So thank you so, so much.
I see Stephen has a question. Yeah.
Not a question so much as question and comment. I just Googled it. They say that if you are a guest, you're not allowed to chat, because I also don't have chat in my screen. But if you are a member, then you are allowed to chat.
Ah,
Then
okay, but so that's interesting. Thank you for that information.
Yeah.
I do see. Yes, go for it. Okay.
And the second thing is, how do you join the WhatsApp group?
So if you just send me an email with your name, I need first name, surname, and cell number, because it's a WhatsApp group on your phone. So if you email Jenny at theanswerseries.co.za.
The first name, okay.
Yeah.
Also, if
Thanks.
the feedback form also has the option to add in that you would like to request to be invited. Yeah. So that's the other way to do it.
I'm just wondering with Teams, because everything that we're going to be presenting this year will be on Teams. So if you are able to download it, then you will have full access to all the functionality. So it might be an idea to do that for future webinars that we have, if you are able to do that.
Has anybody got any geometry questions or any questions for Anne on the presentation? Because we don't want to drag this out. So, Samile, what would you like to ask?
Okay, thank you. Oh, thank you so much for the wonderful presentation. I really enjoyed it. And I did submit the feedback form as well and my contact number so I can be added to the group. So the question I had is in grade 10, we do have an investigation about the midpoint theorem. But now in grade 12, we do prove the proportionality theorem. So now I was wondering, can it occur that there will be a time where a proportionality theorem can become a midpoint theorem somewhere? Because I have been wondering if can this basically be true, or is the way in the manner in which we do prove a proportionality theorem in grade 12 more or linked to the way learners should understand the midpoint theorem in grade 10? Thank you.
Who wants to answer?
I'm happy to.
Perfect.
Yeah, I think that one proves it very differently in grade 10, as specifically the midpoint theorem using parallelograms.
Oh, okay.
But when you do get to the proportion theorem, it is more a way of looking at, well, this is a general theorem of which the midpoint theorem is a special case.
Oh, all right. All right. Okay.
So it kind of happens the wrong way around, you know. You should perhaps have got the general one first and then said, oh, wow, now if we've got midpoints, then look at that. Look what happens now, you know. But it just so happens that I like the fact that they do introduce the midpoint theorem in grade 10, but I can understand why you are questioning that.
Okay, thank you so much.
Sure.
If I can just add to what you've said, not anything different, but the grade 12 exam in 2021 the question right towards the end that the learners found so difficult was quite challenging if you try to do it with the proportionality theorem, and incredibly quick and easy if you use the midpoint theorem. So lots of teachers take the approach that it's not worth bothering with the midpoint theorem because the proportionality theorem covers it. But in fact, the proportionality theorem requires a lot of steps, whereas the midpoint theorem accepts a one-statement answer. So it is definitely worth making sure that they understand that theorem. And also, when I've been doing research for videos on patterns and sequences, for example, quite a number of questions actually make use of the midpoint theorem for sums to infinity. So there are different applications of the midpoint theorem which pop up quite unexpectedly in the weirdest places. So it is definitely worth making sure that your learners can handle it.
Thanks, Jane.
Any more questions, anybody? Okay, I think with our...
Jane, there's one question around, and it's probably for the whole team, just to kind of say that we've started this whole idea of supporting through maths specifically first. There's a question about other subjects. I don't know if either of you would like to speak into our kind of bigger plan, potentially, or just to watch this space for now.
Okay, so what I can say, which will be of interest, I'm sure, to a number of teachers who are teaching maths and maths literacy, is that Maths Literacy is planning a webinar which they are hoping will take place towards the end of February. And then from there, they will grow their program. So we've had the advantage of having a bigger team in our maths group, and we've been planning things for a long time. And now we're stepping out, which is working brilliantly. Other subjects are going to follow suit over a period of time. And the first one of those subjects is undoubtedly going to be Maths Literacy. And then from there, there'll be a rollout. So watch the space. But for now, the strong support is coming through in maths, largely because we feel like it's the area where the majority of kids are going for extra lessons, and the majority of maths teachers are feeling that they're suffering from burnout. So we've hit the biggest, not the biggest subject in terms of numbers, but probably the most pressurized subject in terms of results. Yeah, we'd love to do it all at the same time, but it's a little bit impossible.
If I could just, while people are thinking about it, maybe asking a question, to say that one of our purposes, especially if you consider what has been our experience over the past couple of years, almost an unintended benefit has been this realization that actually learners can more and more take responsibility for their own learning. And that's a great gift to you as a teacher, to know that you guide and you provide and you're there for their discussions and their questions and whatever, but it is impossible for you in any case, even in full-time teaching, to teach every single fact that they need to know. So the more they're aware of the fact that it's their responsibility, then that we give them the material to actually help themselves as much as possible. And that is why we are called the answer series, because we believe that the children should have the answers at hand, which is, I know, very different to what some people think, because they think, oh, then they'll just write it down. But for me, what we like to teach is a way of thinking. And if you have the answer right at hand, you can immediately know if your train of thought is correct or not, and be supported by that. And not only find out 2 weeks later that you had the wrong answer, which especially in the trying conditions of teaching at the moment, is extremely valuable and important.
Okay, I think, Gretz, do you want to close off?
Yes, with pleasure. Sure. Just been an incredible afternoon together. Thank you, everybody, for your participation and for contributing. Oh, I see one more hand up. Maybe we should just take that one question before I close. V Don Dash? Not too sure. Just remember to go off mute if you are trying to speak. There we go.
Okay, can you hear me now?
Yep, go for it.
Hello?
Yeah,
Yes,
go for
we
it. We
can
can
hear
hear
you.
you.
Okay. Thank you. Thank you very much for the great presentation. I'm actually trying to get the free ebooks. I don't know whether I have clicked on something wrong, but because it actually took me straight to Snaplify.
Yes.
That's correct? Yeah?
That's part of the process. It's unfortunately it is a process, but stick with it. And if you are having any problems, just get in touch with us. I'm just thinking who's the best to email.
Okay.
Probably Gary at the Answer Series. Let me just pop that into the chat for you. So again, first names. Yeah, so apparently it is a process, but it will work.
Okay, thank you very much.
Okay.
That's what I wanted to know. Thank you very much, guys.
All right. Take care. All the best.
Okay.
Sure. So yeah, thank you, and thanks again, Mum, for your inspiration and enthusiasm, and to the team also, just that extended, and to all the teachers, good luck and all the best for this first term, and we will see you soon.
Hopefully at the trigonometry webinar on the 16th, is it, of February?
16th of Feb. Yes,
Yep.
there we go.
Yep.
That's a good,
Yep.
good day to put in the diary.
Yeah.
All right, great. Bye-bye, everybody.
Bye-bye. I can't see them. Will I be able to see them afterwards?